In this video lesson we're again continuing with the topic of trigonometry C, and we're looking at the wave function, specifically this time where we have the presence of multiple angles. So we'll just continue with an example because it's not that different from when you've got single angles. So we want to write 5 cos of 2x plus 12 sine of 2x in the form k times sine of 2x plus alpha, where k is greater than 0 and alpha lies between 0 and 360 degrees. So as always, we'll just have a wee quick look at the graph of 5 cos of 2x plus 12 sine of 2x. And at the end, once we've re-expressed this in the form k of sine of 2x plus alpha, we'll check that the graphs are exactly the same. So we'll expand what we've been given here, and that gives us k times sine of 2x times cos of alpha plus k times cos of 2x times sine of alpha. Equating coefficients, so if we look at our sine of 2x's first, you can see that that gives us k times cos of alpha equal to 12. We then look at cos of 2x, you can see that k times sine of alpha is equal to 5. We've now got our simultaneous equations, so we can now try and solve for k. So squaring each equation gives us k squared sine squared of alpha equals 25 and k squared cos squared of alpha is equal to 144. Adding these together gives us what's on screen, and you can see on the left hand side that we've got a common factor of k squared, and on the right hand side we've got 169. Now remember, on the left hand side, sine squared of alpha plus cos squared of alpha is equal to 1. And we can conclude here that k is equal to 13. Now we need to solve for alpha. So we know that k times sine of alpha over k times cos of alpha is equal to 5/12. Our k's simplify to 1, and we know that sine of alpha over cos of alpha is equal to tan of alpha. So tan of alpha is equal to 5/12, and we just need to identify which quadrant our angle is coming from. So looking at k times sine of alpha, that was positive, so that's the first or second quadrant, and k times cos of alpha was also positive, so that's the first and fourth quadrants. So that means our answer is coming from the first quadrant there. So inverse tan of 5/12 is 22.6 degrees. So we can now express 5 cos of 2x plus 12 times sine of 2x in the form k sine of 2x plus alpha, and that gives us 13 times sine of 2x plus 22.6. And if we look at the graph of that, we can see there that it matches 5 cos 2x plus 12 sine of 2x. And again, you can see here, I can compare the graphs again, but I could actually have been asked to express 5 cos of 2x plus 12 sine of 2x in different forms. So I could have been asked for k times sine of 2x minus alpha, and you can see our phase angle is different, but we have again the same graph. And we could have used either expansion for cos as well, and you can see again that we would have the same graph. So just back to that example to allow you to copy that down before the screen goes blank, and then complete the assigned exercise for today.